Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to continue our discussion on how to graph lines, but we're going to talk about a new form of a linear equation, point-slope form. So the equations that you're given are not going to look the same as what they did in our previous video, but we're going to learn that we can still graph them even though they look a little different. So to start off, again, let's see what you remember about point-slope form. Go ahead and see if you can identify either the y-intercept or a point or a slope from that equation. The y minus 7 is equal to negative 2 times quantity x plus 3. And then see if you can graph it. Maybe you can't graph all of it, or maybe you need to change the equation a little bit to help you graph. But take a minute or two and then join us back for a discussion. Okay, so what I think most of you probably did, right, is you may have converted this to slope-intercept forms. You may have taken a look at this and said, maybe I can see the slope. Maybe you picked out that the slope was negative 2, but I don't know what my y-intercept is. And that's what we did in our last video. We found the y-intercept, and then we either used the change in y over change in x to find another point, or we substituted in something for x to find another point. So again, I'm thinking that some of you may have rearranged this equation. Maybe you distributed. So you got y minus 7 is equal to negative 2x minus 6. Maybe you then added, well, that's not minus 7. That looks like equals 7. Minus 7. Maybe then you added 7 to both sides. So you got y is equal to negative 2x plus 1. And then you're like, I got it. I've put it in slope-intercept form. I am ready to graph. So you identified your y-intercept. You plotted that point. Again, we're always going to label our points. So I get 0, 1. Then you saw your slope, negative 2. And because our graph is nicely ticked off by ones here, I can just use the change in y over change in x. Just going to write that out real quick. Slope is equal to change in y over change in x. Remember that triangle is called delta, but really means change in. And I get negative 2 over 1. Right? You can always make that negative 2 a fraction by putting it over 1. So I go from this point, I go down to change in y is negative 2, and I go 1 to the right because I have positive 1 for my change in x. This new point is 1. Let's do it on the other side so I don't run into my line. This new point is 1 comma negative 1. And I am good to draw my line. Perfectly acceptable way of graphing this equation, right? However, there was a slightly more efficient way we could have done it, right? We didn't have to convert it to slope-intercept form, but to do that, we would have to understand what point-slope form is. So I'm going to erase what we have, and we're going to talk about it as far as point-slope form goes. So for point-slope form, our slope is the number right outside parentheses, but our y-intercept is not given. Okay, it's there, but it's just not given with one of the numbers that we're seeing. What is given is one of the points on the line. We can look at this negative 7 and this positive 3, and we can know that one of the points on the line has to be negative 3, 7. We'll talk a little bit more about why it's negative 3 and positive 7 when it looks like it should be negative 7 and positive 3, but this would be one of the points on the line. So I'd go over on my graph, I go to negative 3 up to 7, which would actually be somewhere up here. right? But we can see that this line does end up going through that point. I'm going to label it, of course, -3, 7. And then we could use our slope from that point to find our other point, right? So I could go down 2, could go over 1, and there would be another point on my line at -2, 5. And I could go ahead and draw my line between those 2 points. Again, I know we didn't go into exactly what point slope form was. You're still probably have questions about it, but we're going to do that below. I just wanted to show you that with understanding point slope form, we could have graphed this line using less work than we did having to convert it to slope intercept form. So let's go ahead and talk about point slope form and then get some practice in. All right, point slope form. Maybe you've seen this before. Y minus y1 is equal to m times the quantity x minus x1. So we should at least recognize our m. Our m stands for slope. But what about this x1 and y1? Well, that x1 and y1 is one of the points on the line. So it's kind of like the y-intercept. It's not the y-intercept, but it's like the y-intercept in the sense that we could plot this point right away and then use the slope to help us figure out another point. Or use another method, which we'll talk about later. So if you can identify that x1 and y1, you can plot that immediately on your graph and then use the slope to try to figure out a different point. Now, here's the tricky part. Right? This is y minus y1 and x minus x1. So if we have an equation like y minus 3 is equal to 4 times the quantity x minus 2, our x1, y1 would end up being 2, 3. Not -2, -3. All right? So it's the opposite of what you may think it would be. Now, if I have the equation y plus 4 is equal to -2 times the quantity x plus 1, my x1, y1 would end up being -1, -4. So again, it's the opposite of what you're seeing in the equation. Now this has to do, right, because the equation says y minus y1. So you're just taking this number after the negative sign. You're not including the negative sign. But if you have an equation like y plus 4 is equal to -2 times the quantity x plus 1, which is what we had over there, I could rewrite this so that I actually see that negative sign. It could be y minus -4 is equal to -2 times quantity x minus -1. Right? Because point slope form is y minus and x minus. So if we have some pluses in here, well, we can think about it. The only way we could change that to a minus and have y minus something and x minus something is if we change those other numbers to negatives as well. All right, so that's the long reason, right? The shortcut is just think about I need to take the opposite of those two numbers, right? If it's y minus, well, my y coordinate is going to be plus. If it's y plus, my y coordinate is going to be minus. Okay, let's get some practice with this idea because I know it's a little confusing. All I want you to do in these 4 examples is give me the x1 and the y1. Okay, so the x1, the x1 and the y1. Tell me what that is in all four of these. Okay, so in the first one, my x1 is positive 1. My y1 is positive 5. In the second one, we'll call this one 2. I'll just label these for us so you have some reference numbers. In number 2, my x1, it's still x minus 9, so my x1 is 9. It's y plus 5, though. So I'm going to have a negative 5 for my y1. For number 3, my x, it's x plus 7.8, so my x1 is really negative 7.8. And my y1 is positive 4.2. And in my final one, this one looks a little different actually, right? Where's the parentheses next to the x? Well, I could rewrite this as y plus 4 is equal to 3 times x. You could do minus or plus 0, it doesn't matter. I'll do minus because that's how point slope form is written, right? If you don't see that other number in parentheses with the x, well, we can assume it was 0. So my x1 this time is 0. My y1 is negative 4. Again, the opposite of what we see there. This is the first skill you have to be able to perform when graphing using point slope form. You have to be able to identify that initial point. Then the process is similar to what we did in our last lesson. So let's go through that whole process now. Again, pause the video, try to graph this equation on your own, and then join us and see how you did. So first thing I'm going to do is identify my x1 and my y1. That's going to be 1, 2 here, and I'm going to graph that right away. One, 2. Now I need to find that second point. So because this graph is nicely ticked off by 1s, I can use my slope. Right? My slope is equal to change in y over change in x, which in this case is 3. I can make that a fraction just by putting it over 1. So my change in y is 3. I'm going to go up 3. Change in x is 1. I'm going to go over 1. And there's my new point. That looks like it's at 2, 5. So I can go ahead and sketch my line between them. That wasn't great. Let me redo that. A little better. And again, I'm done because I only need 2 points to graph that line. Let's go to the next one. You'll notice that this graph now is not ticked off by 1s, it's ticked off by 2s. So I'm going to ask you to use our other method. Instead of counting up and over or down and over, find that second point in a different way. It was the other way we learned how to find points in the previous video for lesson 5.1, right? Where you substitute in any value for x and you figure out what that y value has to be to get your new point. Okay. First thing I can do, though, is, again, get that first point. My x1 is positive 1. My y1 is negative 4. Again, it's the opposite. I'm going to graph that. 1, negative 4. So I'm going to go halfway between 0 and 2. And again, it doesn't matter if you get the point perfectly on the graph, right? You're not going to get it perfect because you're not a computer and you can't go exactly between two numbers. That's okay as long as you label it, right? As long as you label it as 1, negative 4, because then I know what you mean. Now, because this graph is not ticked off by ones, we're not going to count, any blocks for change in y over change in x. I'm just going to pick a random number for x. I'm going to pick a number between negative 16 and 16 because those are the numbers on my graph. And I'm going to go with 4. So when x at x is equal to 4, I get y plus 4 is equal to 3 times the quantity 4 minus 1. So I get y plus 4 is equal to 3 times 3. I get y plus 4 is equal to 9. And if I subtract 4 from both sides, right, that's going to give me y is equal to 5. So my new point is 4, 5. And that's what I can go graph. So 4, again, 5 is somewhere between 4 and 6, right in the middle there. I'm going to label it as 4, 5. And I am good to draw my line between the points. We have successfully graphed the line. So again, when the graph is not ticked off by ones for you, you're going to need to employ this method of finding another point. And it's really good practice algebra-wise too, right? You're having to practice your simplifying. You're having to practice your inverse operations. So it's making you a stronger algebra student for future problems. It's not only just helping you solve the current problem you're on. Okay, I think there's 2 more. And again, graphs look different, right? They're not always ticked off by ones here. In fact, none of these are. So you're going to have to employ that method from above in finding the second point, right? You can always identify your first point by finding your x1, y1, because these are in point slope form. But your second point, you're going to have to choose a number for x, substitute in, and figure out what your y should be. Also, don't be afraid to use a calculator here to help you simplify. Working with decimals, it's not a problem to use a calculator to add and subtract them. We are going to stop the video here. You can practice these on your own. If you have any questions, feel free to bring them to me. We also will probably go over these in class as well. So that's where we'll end here. As always, enjoy the rest of your day, and I look forward to seeing you next time.